In this video, we're going to look at graphing an equation. So before we start this lesson, some things you should be comfortable with is the coordinate axis, right, the XY plane, the order of operations, and then solving linear equations. All right, so if you know all that stuff, you'll be comfortable with this lesson. All right, so first thing, just really quickly, I said you should already know the coordinate axis, just to remind people, going left and right, this is your x-axis, and going up and down, this is your y-axis. All right, so I want to plot the point 4, -2. This is my x value, that's my y value. I go right on this axis 4, 1, 2, 3, 4. I go down because it's negative on my y-axis, 1, -2, and those meet at this point 4, -2. All right, so that's my coordinate axis, and that's a point on it. All right, so to graph an equation, the point x comma y is on the graph of an equation if those x and y values make the equal sign of the equation true. All right, so consider this equation, 2x plus 4y equals 8. Is the point 2, 1 going to be on the graph of this equation? Well, what I'm going to do is plug in 2 for x and 1 for y and just see if the equal sign makes sense. All right, so 2 times 2 plus 4 times 1 equals 8. Now I simplify, 2 times 2 is 4, 4 times 1 is 4, and I get 8 equals 8. Does 8 equals 8 make sense? Yes, it does. So this point is on the graph of the equation. What about the point 3, 2? Do the same thing. 2 times 3 plus 4 times 2 equals 8. 2 times 3 is 6. 4 times 2 is 8. 6 plus 8 is 14. Does 14 equals 8 make sense? No, it doesn't. So this is not on the graph of the equation. All right, so that's how you can verify if a point should be on the graph of an equation. Just plug those numbers in. If the equal sign is true, then it's on the graph. All right, so what's the actual strategy for making a graph ourselves? All right, the full graph of an equation. All right, you can pick any value you want for x, and we'll talk more about what values make sense as the year goes on. But to start, just pick any value for x, and that'll force the equal sign. When you solve that equation, then you can force to figure out what the y value has to be. All right, so when you pick x, the equation will tell you what y has to be to make an equal sign true, and that'll give you a point xy that has to be on your graph. And you just keep doing this until you're like, oh, this has to be what the graph looks like, and having a little bit of kind of extra information about what graphs look like in general will help. All right, but really you could just do this forever. You could do 100 points and just make sure your graph is exactly right. All right, so we're on a graph 2x plus 4y equals 8. All right, so I'm gonna make a little chart, and my x values are here, my y values are there. Again, you pick the x value. X is the input. You can pick x to be whatever you want. All right, so I'm going to do 3 points for this example. And generally, you just want to pick numbers that are a little bit easier to work with. So 0 is always a number I would try because 0 is super easy to plug in. It just makes things go away. Another number that's pretty easy to plug in is 1. All right, so that's the next number I would try. And then just some other point, let's just try like -2. That way we have a negative number in there and it's a little bit bigger. All right. So if we do 0, we're going to get 2 times 0 plus 4y equals 8. And again, the great thing about 0 is it's going to make that first term go away. So I get 4y equals 8. Divide both sides by 4, y equals 2. So that tells me when x is 0, y has to be 2, which gives me the point 0, 2 on my graph. What about the next point? I'm plugging in x equals 1, 2 times 1. Plus 4y equals 8. 2 plus 4y equals 8. A couple more steps to solve in this case. Now I got to subtract 2 from both sides. And now I can divide by 4. Y equals 6 over 4, which is 3 over 2. All right, so when I put in the x value 1, I get the y value 3 over 2, which you put in that calculator, it's 1.5. So that's there. And the last number that I've chosen is -2. Again, nothing special about the numbers that I chose other than 0. 0 is special because it's always the easiest one to plug in. When I plug in -2, I get -4 plus 4y equals 8. Add 4 to both sides. Divide by 4, I get 3. So when I put in -2 for x, my y value is 3. Right, and for me, that's enough to know what the graph is going to look like. Actually, 2 is enough because I know this is a linear equation, so the graph is going to be a line. But you could keep doing this forever. You could plug in -1. You could plug in 3. You could plug in 5 would be, I think, there. Okay. You just keep doing this forever until you're like comfortable, like, oh, this has to be the graph. Again, if you recognize this is a linear equation, then that just means your final answer is a line. So this is the graph of my equation. All right, but you can graph anything like this. It doesn't have to be linear. Doesn't have to be anything else that I will talk about throughout the year. Any equation that you're ever given, you can always just graph it by picking an x value, figuring out what the y value that goes with it is, and just putting those dots on your graph. All right, so here's another example. Y equals x squared minus 2. You'll notice this is not linear because that x squared, but it doesn't matter. I can still graph it using the same techniques. All right, so I'm going to graph it. I'm always going to pick 0. I'm probably going to pick 1. And maybe I'll just do like a couple more. Let's do like a -2. Let's do a 3. And let's just see what it looks like when we get those ones. All right, so this one is actually going to be a little bit simpler because y is already by itself. So y is 0 minus 2, which is -2. So 0, -2 is 1 point. All right, the next one, y is 1 squared minus 2. 1 squared is 1, and that gives me -1. So when I plug in 1, I get -1. So 1, -1 is on my graph. All right, -2, I'm going to get -2 squared minus 2. -2 squared, when you multiply -2 times -2, you get +4. That gives me 2. So I put in -2, I get +2. And 3. 3 squared is 9. 9 minus 2 is 7. So I put in 3, I get 7, which is just off my graph up there. All right, and maybe for some of you, this is enough points to know like, oh, I know what this graph looks like. Maybe for some other people, that's not enough, so just keep doing more points. I could do -1. If I plug in -1, I'm going to end up getting this point. If I plug in +2, I'm going to end up getting this point. -3, I end up getting that point. You start to see this kind of symmetry with it, and you can kind of make sense that the graph should look like this. And we'll talk more about this type of graph later. All right, but for now, just plotting some points, getting a general shape for the graph is all we're looking for. All right, so here's one for you to try on your own. All right, graph x minus y equals 1. All right, so figure out, just make sure you have the basics of graphing down, and I'll show you the solution in 3, 2, 1. And here's the answer. You get this straight line. Again, when there's nothing kind of weird going with the x or y, it's linear, so that's your hint that it's a line. I bet any of these points you could have gotten. If you plug in 0, you get -1. If you plug in 1, you get 0 for y. If you plug in 5, you get 4. All right, so it just depends on what numbers you just had to plug in. I bet any of these points together should get you this straight line, connect them, and that's your graph for this equation. All right, so go ahead and practice this skill. All right, again, just working on plugging things in, plugging your x's in, seeing what the y that goes with it is, and putting all those dots on your graph. All right, and one kind of final thing I didn't quite mention is a lot of people just get these dots on their graph and they just leave it like that. But the full graph is always going to be this connected line that goes through your dots. All right, so make sure you actually finish the problem off and draw that full line or curve that goes through all the points that you found.